Hi guys, welcome back to Math with OG. In this video, we'll be looking at closure of a set. Before we look at that, kindly subscribe if you've not done so and don't hesitate to use the like button. Now, as you can see on the board, if K is a non-empty set, if for all, this symbol here means for all, if for all values of A and B being element of K, so I have a set K. I have a set K that is not empty. K is not an empty set. So all the elements in set K, when they operate on themselves, it will also give you an element of set K. Then we can say that set K is closed under the binary operation. If I operate any member of that particular set, it will always give me a member of that particular set. So we can say that that particular set is closed on that particular operation. But if, however, I have one answer that is not a member of the set, it means that that set is not closed under that particular operation. So what I said now might be sounding somehow. So let's use this to explain what we mean. Now let's say we are given this set -1, 0 and 1. Now we want to operate on these guys using our four basic arithmetic operation, that is addition, multiplication, subtraction and division. Let's check if this set is closed under addition, if it's closed under subtraction, closed under multiplication or closed under division. How will I know? If after working with addition, I have one element that is not a member of this set, then it's not closed. But if all the elements I'm getting as a result are elements of this particular set, then it is closed. Now look at this. This is for addition. Now you can see that -1 is adding up to -1 to give you a -2. -1 is adding up to 0 to give you a -1. -1 plus 1 will give you 0. 0 plus this, 0 plus this, 0 plus this. 1 plus -1, 1 plus 0, and 1 plus 1. You can see that the result that we are getting, from this particular set under addition, we are having at least one element that is not a member of the set. So what are the elements? -2 and 2. So because we are having a -2 and we are having a 2 and they are not members of the original set, I can say that this set is not closed under the operation of addition. So when defining it, you need a set and you need an operation. So you say a set is closed under a particular operation, or a set is not closed under a particular operation. So this set is not closed under addition. Now let's move on to subtraction. So if I'm done subtracting, and lest I forget, when solving questions in binary operation, the vertical axis is always comes first. So the column comes first before the row. So it is this operation, this, not this operation, this. So we operate this on the other guy. So if I do this operation on subtraction, I'll be having a -2 here and I'll be having a 2 here. So because -2 and 2 are not members of the original set, I can say that subtraction is not, sorry, the set is not closed under the operation of subtraction. Now let's move on to multiplication. When I'm done with this operation for multiplication, I'll be having 1 0 minus 1 0 0 0 minus 1 0 1. You can see that all the members here are members of the original set. So because I have all these results to be members of the original set, I can say that this set is closed under the operation of multiplication. This set is closed under the operation of multiplication. For division, it's obviously not closed because when you divide by 0, you get an indeterminate value, or some people like to call it infinity. However, be it indeterminate or infinity, is not a real number. So you can see this place is blank. So because of these blank spaces, I can say that this set is not closed under the operation of division. So you can be asked, which of the set -1 0 and 1 is closed under which operation? A addition, B subtraction, C multiplication, D division. The answer is multiplication. This set is only closed under the operation of multiplication. So which other ways can you see your question? You can be asked, your natural numbers, your real number, your rational numbers, are they closed under multiplication? Are they closed under division? Are they closed under addition? Even down to your prime numbers, your even numbers, your odd numbers. So in this case, I'm focusing on natural numbers, integers, rational numbers, irrational numbers, and real numbers. So for those of you that don't know what these numbers mean, you can go and watch our videos on numbers or set of real number system where I explained all these sets and the meaning. That means how to know if an element is a member of this set or not. So let's look at these guys, starting with natural numbers. Addition, subtraction, multiplication, and division is your natural numbers, or are your natural number is your set of natural numbers closed under this operation. So let's start with addition. Whenever you add two natural numbers, what are natural numbers? Positive whole numbers. Whenever you add two positive whole numbers, you always get a positive whole number. So I can say that addition is closed. Sorry, natural numbers is closed under the operation of addition. Natural number is closed under the operation of addition. That's why I put a y here, meaning yes. Now for subtraction, and is a set of natural numbers closed under subtraction? No. You are told that once you can get one result that is not a member of the set, it means that it is not closed. So I can just formulate a result now. 2 is a natural number. If I subtract 5, another natural number from 2, so the operation here is subtraction. This will give me a negative 3. This guy is not a natural number. Negative whole numbers are not natural numbers. Natural numbers are positive whole numbers. So natural numbers is not closed under subtraction. Now, natural numbers close under multiplication. The answer is yes. Pick any two positive whole numbers. When you multiply them, it should give you another positive whole number. So that's yes. And natural numbers close under division. The answer is no. I can still work with 2 and 5. 2 divide 5, which is equal to 2 over 5. This will give us 0.4. 0.4 is not a natural number. Why is 0.4 not a natural number? Because it's not a whole number. So this is a natural number. 2 is a natural number. 5 is a natural number. But when I use division as the operation, it gave me 0.4, which is not a natural number. So natural numbers are not closed under division. Now let's move on to integers. Are integers closed under addition? The answer is yes. Integers are positive or negative whole numbers, including 0. So if I add up any whole number, it will always give me a whole number. If I subtract any two whole numbers, it will always give me whole number. 2 minus 5 is minus 3, an integer. If I take a negative integer, subtract a positive integer, so this is minus 5 minus 4, this will give me a minus 9. This also is an integer. So it is closed under addition, closed under subtraction. Is it closed under multiplication? Yes. Pick any two whole numbers, multiply them, it will also give you a whole number, be it 0, negative, or positive. Is it closed under division? The answer is no. Same reason, 2 over 5, 0.4. 0.4 is not an integer. So you see that it's not closed under division. Or you can also work with 0. 2 over 0 does not have a value. So this guy cannot be closed because of 0. When 0 is at the denominator, this guy will not have a value. So it is closed under addition, subtraction, multiplication, but not closed under division. Next are rational numbers. What are rational numbers? Numbers that can exist in the form of a over b. Numbers that can exist in the form of a over b, provided a and b are integers. So any two rational numbers, when you add them up, it will definitely give you a rational number. Any two rational number, you can pick 2 over 5 multiplied by 7 over 9. This will definitely give you a rational number. This should be 18. This should be 35. So this should give you a 53 over 45. This is also a rational number. So you can check if there's any error, but I know that when I add this up, it will also give me a fraction, which is also a rational number. And remember, all your own numbers are also rational numbers. So it's closed under addition, closed under subtraction, closed under multiplication. Is it closed under division? No, it's not closed under division because of one basic or one number, and that number is 0. 0 is a rational number. So when I divide any number by 0, this will not give me a rational number. This is a rational number, this is a rational number, but it will give me an indeterminate value. So your set of rational numbers is not closed under division. And remember, a rational number is a set of numbers that can exist in the form a over b, where a and b are integers, provided b is not equal to 0. So when b becomes 0, this automatically this automatically cease to being a rational number. Next are irrational number. Irrational numbers, are they close under addition? Yes. Whenever you add up any two irrational number, it will definitely give you an irrational number. You cannot add up two irrational number and get a rational number. For example, your root 5 plus root 3 will give you an irrational number. Root 5 plus root 5 will give you 2 root 5, which is also an irrational number. Whenever you add up irrational numbers, you get an irrational number. Whenever you subtract irrational numbers, you get an irrational number. Irrational numbers, they are closed under addition and subtraction. Okay, let's hold it there. I can see that this guy is a no-no. Irrational numbers are not closed under subtraction. Reason being that root 5 is an irrational number minus a root 5, another irrational number. This will give us 0, and 0 is not an irrational number. So it is not closed under the set of irrational numbers. Then you have multiplication. For your multiplication, is it closed? The answer is no. Root 5 irrational number multiplying root 5, another irrational number, and that will give you 5, which is a rational number. That will give you 5, which is a rational number, making this guy no. Division, is it closed under division? No. Root 5 divided with 5 will give you 1, and 1 is a rational number, so this is no. Now, someone can argue that this is also no, so I'll prove that so that we can change that to no. So I can change this to no. Reason be that I can say negative root 5 is an irrational number on its own. Negative root 5 is an irrational number on its own. So if I add it to positive root 5, another irrational number, this becomes 0. So if this is 0, 0 is a rational number. So addition, or your irrational number, is not closed under addition, it's not closed under subtraction, it's not closed under multiplication, and it's not closed under division. Now, lastly, we have our real numbers. So all these numbers here, they are all real numbers. So whenever you add up any real number, you get a real number. Whenever you subtract any real number, you get a real number. Whenever you multiply any real number, you get a real number. However, it will not work for division because 0 is a real number. 8 over 0 indeterminate, and that is not a real number. Remember, your infinity is not a real number, both negative and positive infinity. So this is how you know if a set is closed under a particular operation. So on your own, you can check for multiplication. You can check for even numbers and odd numbers. So check if these guys are closed under set of even numbers. Check if these guys are closed under set of odd numbers. Also check if these guys are closed. If these guys are closed under set of prime numbers. So you can do that, and you can leave your answer in the comment section, and I'll tell you if your answers are right or if they are wrong. So that's all for closure of a set. In our next video, we'll be looking at some properties or characteristics of sets. That's your distributive law, associative law, and commutative law. That's what we'll be looking at in our next video. Thanks for watching this video. If you enjoyed it, use the like button, use the subscribe button, use the share button. Don't hesitate to leave your comments if there's any error in solution or in what I said, or if you have any question, use the comment section. And thanks for watching once more. See you guys in my next video.